All right, so here we have an example of a geometric model, right? That might be, uh, you know, thousands and thousands of triangles that are stitched together to represent this spherical geometry, right? We probably also might have a couple of circular geometry that represents. Here you can see some of the triangles that are stitched together to represent each one of the faces that are going around. So it does have some detail to this, right? That gives us these kind of ridges, these bumps around. So it's not a trivial geometry, right? It's not only just a sphere, but it also has several circles all around it. Here you have some ridges that represent some characteristics on the surface of this sphere. So it's not a trivial. Also, we notice that there's some specularity that is shown to show that presumably this is some kind of metallic object, right? And depending on how much specularity we add to this, we might make this even further more realistic as being something metallic. But and, if you add some of the mapping techniques, such as some kind of texture that you might have some representation of some marble or some stone or some things that have some kind of grains uh, that we could map around, right? Certainly, we can improve the effects of this looking much more realistic. So this is the result of having grabbing several types of images, right? One for the sphere around that we've wrapped and distorted around each one of the pixels, as we went from one surface to the next, and then mapped each one of the pixels on the source image onto the surface of this sphere. We also notice that we have several specularity points, right? That we have maybe several sources of light from different positions, right? And so this again adds to the realism of the image. Further, we can add some other alternatives. Might be to add some environment mapping, where we have a picture that we took around us, right? And it might be a room, it might be outside, in the woods, in an open air, where we might have some kind of horizon. And then what we did is that same image that we took 360 image, we then wrapped our geometry with that, giving it the simulation or the look and feel as if this is a highly specular object, that it's very shiny, so shiny indeed that it's reflecting its environment, right? Obviously, this is the way we did this is that you take a picture of the surrounding and then you map it on top of a sphere, right, to make it give that look and feel. Plus, additionally, we added some specular points all around from different source points of source of light, again to give it that look and feel as if it's something very, very shiny, metallic. Or alternative, we can again grab that same image. Not same image. Some image that represents some kind of terrain that represents maybe mud or water, or maybe some vegetation with greenery, and then all these ridges, all these additional characteristics, right? Instead of using additional geometry, for instance, smaller triangles for achieving these additional details. Instead, what we did is that we kept the same triangles, the triangle count stays the same, but instead, as we interpolate between the various points on a triangle, we vary the normal, right? And then as the normal changes, we use normal information to decide, how does that normal interact with the light, as it shines on this surface, and so that allows us to add additional look and feel as if this is very bumpy. It has all these additional details, which we're not modeling using triangles. Instead, we are modeling with just varying the normals that as we interpolate over the pixels that represent our triangles.